Hello all, welcome to the series of operating system. In this video, we will discuss about first come first serve algorithm, which is very core algorithm. The criteria for FCFS algorithm is arrival timing. Arrival timing, that means when process enters into the ready queue. As we know, ready queue, that is our RAM where processes are arriving, and then the mode is a non-preemption. So preemption, non-preemption, I have discussed in another video. You can check that. But the mode of FCFS is a non-preemption. That means complete execution of the process. Okay. Now here you can see some processes are there listed in this table with their arrival timings as well as a burst timing. So what is exactly burst timing, arrival timing, completion, and all these definitions I have discussed in another video. You can check that. Okay, burst timing and arrival timing is given, and as per burst timing and arrival timing, we have to calculate the average waiting timing, average turnaround timing using this FCFS algorithm. So in this scenario, we can use Gantt chart. Okay, so Gantt chart is a very famous for like calculating the numericals based on the CPU scheduling algorithms, because FCFS is one of the CPU scheduling algorithm. Okay, so first of all, we have to check how many processes are arrived in the ready state, or you can say ready queue. That is nothing but the RAM. How many processes are arrived in the RAM? We need to check firstly. So it is exactly starting from the zero. That means based on the arrival timings, how many processes are arrived in the ready queue? Only one process, because see, zero is the beginning for P3. That means at the zeroth time, P3 is arrived in the ready queue. So that means we will execute P3 firstly. And what is the burst timing of P3? Burst timing of P3 is a 2. That means for 2 unit, we will execute the P3 process. Okay, you can see from 0 to 2 unit, right? Now, when we are executing process 3, is there any new process arrived in the ready state? Because this P3 is done now. So check at from 0 to 2, is there any process? No, there is no process. But at the third unit, P1 process is arrived. That means from 2 to 3, no process is received in the ready queue. That is why CPU will be there in the idle mode. CPU will not do anything. So that is nothing but the idleness of the CPU. Okay. Now, while idleness, any new process? Yes, P1 is the new process arrived, so we will execute P1 now. For how much timing? The burst timing is nothing but the timing, that is, you can say the required timing required by the process to complete the execution. Okay, so what is the burst timing for P1? 4. That means from 3 to 4 we are executing the process. That means 3 plus 4, that is a 7. Okay. Now, while executing P1, is there any new process arrived? You can see, is there any new process arrived? So yes, P2 is also arrived in between 3 to 7. P2 is arrived at 5 unit. P4 is also arrived, as well as P5 is also arrived. That means in a ready queue now we have P2 also, P4 also, and P5 also. These three are there because already we have executed these two, P1 and P3. Now sequentially check, our criteria is arrival. That means based on the arrival timings, we have to check the processes, whatever arrived in the ready state. Which is the process arrived in the ready state? As per arrival timing, you can see the arrival timing is less for P4, P5, and similar for P2 as well as P4. That is 5. So that means we will execute which process? Process 5. For how much timing? For a 3 unit. That means 7 plus 3, that is 10. Now this P5 is also done. Okay, P5 is also done. Now next, only two processes are there, P2 as well as a P4, and their arrival timings are same. In this case, what we need to do? If arrival timings are same, So process IDs we have to consider. So sequentially P2 is arrived firstly. So P2 will be executed when the arrival timings are same. So P2 will be executed how much for how much timing? For a 3 unit. That means 10 plus 3, that is a 30. Okay. And last one, that is our P4 process, which will be executed for 1 unit because their execution timing is 1 only. That means 13 plus 1, that is 40. Now this is nothing but the time taken by the processes to execute this. Okay, and that is nothing but the completion timing or finish timing or exit timing of that process. Okay, so when P1 is completed, you can see here P1 is completed at this stage here. So that means at this 7. So completion timing of P1 is 7. For P2, when P2 is completed, you can see here is the completion timing, that is nothing but 13. Then P2 is completed at the P3 is completed at the third unit. You can see initially we have executed P3, that is the execution time is 2. P4 is 14. P4 is 14 because at last P4 is executed, and P3 is executed at when at this moment, that is nothing but the 10. Okay. Now turnaround timing. Turnaround timing is nothing but the completion timing minus arrival timing. So completion timing for P1 is 7 minus 3. Arrival timing is 3. So that means 4. Completion timing of P2 is 13 minus 5. That is 8. Right? So then turnaround timing is equal to completion timing minus arrival timing. So completion timing is 2, right? And arrival timing is a 0. That means 2 minus 0 is a 2. 14 minus 5, that is 9. And 10 minus 4, that is 6. So what is the waiting timing? Waiting timing is nothing but the turnaround timing. So this turnaround timing minus the burst time. So turnaround timing for P1 process is 4, and burst timing is also 4. That means 4 minus 4, that is a 0. Okay. So 8 minus 3. 8 minus 3, that is a 5. Then next one, turnaround timing is 2 minus burst timing is also 2, that is 0. Then turnaround timing for people process is a 9 minus burst timing is a 8. So 9 minus 1 is equal to 8, right? And for the last process, turnaround timing is 6 minus burst timing is a 3 is equal to 3. 6 minus 3 is equal to 6. And now last, response timing. Response timing is also very important, but for FCFS it is not required. Still it is mentioned, or we calculate that. So response time is that the time at which a process got the CPU first time minus arrival time. So remember that this definition already I have discussed in the video. You can check that. Response time, that means when initially CPUs are received to that particular process P1 here. When initially 3. 3 minus arrival timing. 3 minus arrival timing. So 3 minus 3, that is a 0. Okay. Then when process CPUs are received to the second process, so you can see the arrival timing for P2. When first time CPU is received for P2, that is 10. 10 minus arrival timing. Arrival timing is a 5. So 10 minus 5 is equal to 5. So again here for the third process, when P3 process is initially assigned at the 0 timing, 0 minus arrival timing is also 0. So again 0. And here when initially P4 is given, when initially we provided a CPU to the P4 process, you can see here 13. This is the initial timing for P4. 13 minus arrival timing. What is the arrival timing? 5. So again 8. Okay. And at last, when we provided CPU to the fifth number process, here you can see the 7. So here 7 minus arrival timing is 4, again 3. You can see waiting timing and response timing is the same for the FCFS algorithms. That is why I mentioned that there is no need to calculate the response timing for FCFS algorithm. Now our question is average waiting timing. Average waiting timing. So whatever values are there, 0 plus 5 plus 0 plus 8 plus 3. So total average is that is 16, right? 16 divided by 5, and total turnaround, so 4 plus 8 plus 2 plus 9 plus 6, so near about 29 divided by 5. So whatever answer is there, I think here 5.8 unit, and 16 divided by 5 is equal to 3.2 unit. So likewise we have to calculate this. Okay, so in the description I have given one example for you. You can solve that. Okay, and you can comment the answer of that example. Okay, so thank you so much.